Hello everyone, hope you all had a good weekend and relaxed a little bit after your first quiz. So today I'm going to demonstrate to you first the idea of minimization problem and second how to do that in our Excel. Okay, so I thought because we just learned maximization, I thought just to put both the maximization and minimization side by side will make it easier to understand. So you all probably remember the Flair Furniture Company data. So that was our maximizing problem, right? So that was our maximization problem, right? And this is what we're going to learn is minimization problem. I thought that if I go through max and then convert that to minimization, it will make it much more sense. Okay, so let's have a look here. So what we have here, so remember your maximization problem. Now here was your input, right? So you have two inputs. You had your carpentry and painting and varnishing. That was your two input. And these two were the decision variable, right? And this is your objective part, right? This was your objective to maximize the profit, right? This was your objective. Right, this was your objective, and this was the constraint, right? This is the maximum they could actually use. So think about this. You have your decision variable here, you got your inputs here, you got your objective here, and then that's the maximum hours available. You can't go more than that. So if I can bring your memory back, it will be looking something like this, right? Maximize the profit. Yep, if you look into that, so you have your 4, 3, 2, 1 and 70 profit per unit, right? And 50, you just put that up there. So once you do that, you come up with this, as I showed you. This one here comes up, right? So that's for our maximizing problem. Now think about this. Minimization is exactly same in terms of how you put the data in the table. So you have your decision variable, that is brand 1 feed, brand 2 feed here, right? And again, let me just explain what it is. So there is a business that actually brings up turkey growth, turkey farm, right? Now the problem that they have here, the linear programming they're going to use, is there are two kinds of brands, right? Brand 1 feed, brand 2 feed, and these are the ingredients that we have. So these ingredients they must have in the food that they actually give to turkey. Now there's a minimum requirement that you minimum need to have in the food 90 pounds, 90 units of 90 units of ingredient A, and this should have 48 units. This should have 1.5 unit. So the issue we are facing here is there's two brand of feed. Just like here, you need to combine these two tables and chairs. In minimization, you do need to compare. So you need these two are decision variables. So we need to have combination of brand 1 and brand 2 feed, right? In such a way, right, that it needs to meet this requirement of minimum of 90, right? So we don't know what combination it will be. So this, in some ways, well, remember it was inputs here. We sort of cannot really say it's input, but it is a bit like input here. So you need to have that, and you need to have minimum here. So that's what it changes here. So when you had available hours here on the Flair Furniture, you had less than or equal to sign, but here you need to have minimum of that 90, so it's greater than or equal to for all of those. Okay, make sense? Right, so basically all the same decision variables, kind of input, and that the minimum that you should have that greater than. So you have that, right? Now remember you had profit here, right? So profit was 70 per unit of table and chairs per unit of table here. But in case of our minimization problem, it will be the cost, right? So 2 cents per unit of per pound here, right? For brand 1, and brand 2 feed is 3 cents. So what we need to do, we need to minimize the cost. At the lowest cost, we need to minimize this cost per pound, but they needs to have minimum of this, that is anything equal to or greater than for the nutritional requirement, right? That's what. So how would it look like in the table format, for example? So here we go. Make sense? Have a look here. So let me just make it right so you can see both. So let's say we give it a name here. Now there we have T and C, tables and chairs in maximization problem. Here we'll give brand 1 will say X1 and brand 2 will say X2. Okay. Now minimize cost. So this is 2 per pound. So 2 times per pound of brand 1 feed, that is 2X1, plus 3 times X2, which is the brand 2 feed. So multiply that. So you need to minimize this cost. So remember, in your maximization, you need to maximize the profit. It's completely opposite. You need to minimize it. And then after that, you have this constraint. So constraint is 5 times brand 1 feed plus 10 times brand 2 feed. Has to be minimum 90 nutrition for the turkey. Otherwise, turkey will not produce good meat, right? So you put all of those constraints. See here, there is only 0 brand 2 feet, so there is no X2 here. Okay, so all of this constrained here, right? And at the end, non-negatively constrained, because you must have some of this to feed turkey, right? You can't have negative, sorry, I beg your pardon. This means that you can't choose, you cannot have negative, right? You can have 0 of something, but you can't have negative, right? Alright, so makes sense. So this is our data. Now what we're going to do, we're going to actually go and solve this in Excel. Right, so keep all this here. We'll keep this table here, and I'll open up my Excel sheet here. Right, so all good. Right, so what is the first thing? Let's give it a name first here. Okay, so we're going to say holiday meal turkey ranch. Okay, so I'm going to do that, and I'm just going to bold it. Now next step we do is that I have my variables. Now this variables will be how many units. So this is a decision variable. How many units should be produced, we don't know yet, but I'm going to give it a name. And then our objective function. Okay, objective function. And then I'm going to put my brand 1 and brand 2. Right. Units produced, I don't know. That's what we need to determine, right? This units produced is, if you look into that minimizing problem here, there you go. X1, X2 are the units produced. We don't really know what that is, right? So, don't know. Objective function is the cost, right? So I'm just going to put that here, cost, right? And my cost here is 2x1 times 3x2. So 2, 3. Now remember, what we need to do, we need to create this cost function so that the Excel knows how to minimize then. So what we do is that 2 times x1 plus 3 times x2. Now you can manually do that, but we use what we call sum product, right? So you got sum product, right? Select this array, put comma, this array, right? If you want to check, if you put 1 in here and 1 in here, I should get 5. So 2 times 1 is 2, 3 plus 2 is 5. So that's fine. That is correct. Always do that check. It's always helpful. Now we move on to the next one where we actually have constraints. Okay, so we have 3 constraints here. We got ingredient A, ingredient B, ingredient C. Okay, so let's say ingredient A, right? And I'm just gonna do this: ingredient A, ingredient B, ingredient C, right? And now what are those constraints? So we just need to get this figure here. Once again, it's the number. So you got 5 and 10. So you got 5, 10. Now remember, this need to multiply with our decision variable, and then it needs to be greater than or equal to that figure, right? Which figure I mean? This figure here. We'll put that figure later on. So 4, 3. So you got 4 and 3. And then the last one, we don't have anything for x2, so it's just 0.5 and 0. That's sort of constraint. And then we have here left hand side, right? That's sort of LHS. Now what is our constraint limit here? Not limit, sorry, the minimum that we require. So LHS, that is the minimum I require, is 90 for the ingredient A, 48 for ingredient B, and 1.5 for ingredient C. So you got 90, 48, oh sorry, okay, right. Now this is here what we don't know, right? How much will actually be used up? That's what that is there. It's not the actual figure. Remember, we need to put greater than or equal to sign first, right? So this is what we don't know. This is what we don't know. So once it is figured it out, this will calculate this here, right? Now what we need to do, we need to do the exact same thing here, just how the cost has worked. We need to take 5 times that plus 10 times that and then add them up. So that's what we call is equal to sum product, right? And you have this comma this, okay? So that's your sum product here. Now there is a way, you don't need to keep selecting all the time. There is a way you can actually fix this cell. Remember, you can actually drag in Excel, you can drag, it will copy itself. So how we can fix this there, you just put a $ on the formula area here, right? $ here, $ here. So what that means, if you put $ there, okay, yes, I did something a bit funny here, $ in the front of that, yes, there we go. Now if I put $ in there, if you scroll it in here, see, this remains the same, but the scroll in, it takes automatically, that's the count, because otherwise if you don't have that, for example, if you don't have that, I'll show you what happened. If you don't fix the cell, what's going to happen? So if you don't fix the cell, see, this one was fine, this was selecting these two. Next one, see, it moved one a row down. That's what happened when you drag it. So that's why what we do is we put $ value here, $ value here, just to fix that cell, right? So what we're telling Excel, hey Excel, look, this one here that I'm talking about, right? This one here, what I'm talking about here, sorry, let's just do it again. Do it again and do it again. Right, so here you go. So what I'm telling Excel is, Excel, I'm going to drag it. So I want this to change, right? But I don't want that to change because that's my decision variable. So if I do that and then come in here and scroll, it does your LHS, right? So these and these need to be figured out. Now remember what, once again, this is the actual value, right? Because remember, when we have the amount of units that been determined that minimizes the cost but meets the minimum requirement of the nutrition, it will find the figure, but then we need to know how much ingredient A it includes, ingredient B includes, ingredient C includes. Hopefully once it finds the optimal solution, you notice it is at least 90 or even greater, okay? So let's have a look. Now I'm just going to put a sign in here because we want to have greater than here, don't we? So symbol greater than, set, done. So greater than, and I just like to make it bold and in the middle, okay? So that's what it now. Remember, have a look, always go back to your question here. See, it's greater than. And now we put the constraint, so it's 98, 48, and 1.5. So our RHS, or right hand side. Now what I mean by, usually in mathematics what we do, we got this sign here, greater than equal to, or less than equal to, or even equal to. This side we call left hand side, and this we call right hand side, okay? So put there 90, 48, and then you have 1.5, right? So this is all your data done now. Okay, now let's go and use Excel solver to solve this. So data, click solver. My set objective function is here. Remember that formula has objective here. So set that. Changing variable, I want to change, this is a variable that changes, I have a decision variable, and add the constraint. Now we can have constraint is, that is what's going to be determined, is greater than or equal to this constraint here. Alright, okay, that constraint is done. Make constraint variable non-negative. This is this one here, right? And then simplex LP solve. Okay. Ooh, there is some sort of issue here. Let me just check what I did here. You guys probably have figured out what I did wrong. Remember, it was ticked on max here, right? But we are doing a minimization problem. So here, right? So that should be the correct answer. Yep. So it's very, very important that it's a minimization problem. Okay, otherwise it will not. So there we go. When we do, we learn it, and hopefully won't that make mistake. So does it make sense? So have a look. You should have 8.5, 4.4 unit of brand 1 and 4.8 units of brand 2, right? And the cost will cost you 31.2 per pounds. And this is limit, so yep, that's minimum 90 here, 48 equal to, and yeah, ingredient C, much more on ingredient C of 4.2. So I guess why is ingredient 4.2 much greater than that is perhaps ingredient C doesn't really have you know, much of brand. It doesn't have brand 2 there, so perhaps that's the reason what it is. But anyhow, this is your answer, and hopefully that does make sense and hopefully helps you. Okay, take care now. See you in the class.